So yeah, that's about me, and I'm very happy to have opportunity to co-chair this with Mark. So the plan for like basically this introductory session is to just make sure everybody knows each other, so that because we are spending next few hours in this, and it will be great opportunity if we have comfort zone to ask questions and have like very meaningfully answer those questions and help each other. So with that as a goal in mind, the agenda, like you have seen on the website as well, is going to be focused on first this introductory session, followed by we will have specific paper sessions. And then we will have, so we have organized these papers in the group such that first two papers are more computing centric, and the last three papers are focusing more on actually the major emphasis on the non-computing sciences heavily. That's part of integral part of web science. So that's basically the like the intention of why the presentations have been ordered in this way. And we will have, after two presentations, the first group of presentations, a social engagement break, in which basically you are welcome to have interaction with your fellow PhD colleagues, and yeah, feel free to mingle with each other and understand each other's research interests, and build network over there. And then we will have the second paper group session after the social engagement session, which focuses more on the cyber crimes to all the way conflicting narratives, and basically how do we handle the social harm on the web there. So so in that kind of space, we will have like focus more on this, as I said, like this other forms of major challenges in web science, not just computing. And then we will have after that one mentors advising session. So in mentor advising panel is for the purpose of having you guys an opportunity to ask questions to our mentors for like a variety of topics in terms of your training for PhD, just not focused on your research topic as well. So that's being like the broader vision of why we want to have that mentor advising panel. And after that, we'll just finish the session. So yeah, this being the agenda, I want to now introduce our mentors. So we will have three mentors with us. Dr. Deepak Padmanabhan P. He goes with Dr. Deepak P. He's from IIT Madras and Queen's University Belfast, and expertise in computing. We have Dr. Ruth McAllister. She's from Ulster University and with expertise in criminology. And we have Dr. Suzanne Helford, who's expert in sociology, in fact, president of British Sociological Association, and she's from Bristol University. So basically the limitation of time and the time zones, we were managed to have Deepak for the first mentoring our sessions of PhD presentations, and for the second one, where actually we have basic computing and other sciences focused topics as well, we will have Dr. Ruth McAllister join us as well. And in the mentor advising panel session, so you don't feel that we only had interaction with two mentors, we also have then Dr. Suzanne Helford join us in the mentor advising panel. So in this way, we'll try to create some different experiences for you to give you opportunity to interact with the mentors and get more feedback. So this is our plan, and with this, I want to suggest that we can actually have a quick round of introduction from the mentors as well as students as well. That will be great. How about we start from mentors? Deepak, do you want to say a few words, please?
Yeah, sure. Well, thanks, Hemant and Mark for roping me into this nice opportunity. Really appreciate the being able to be part of this the PhD symposium. So my name is Deepak, and I work with Queen's University in Belfast. I'm also an adjunct faculty member at IIT Madras, and my interests over the last 1.5 decades has been mostly around machine learning, NLP, information retrieval, and databases. But recently, over the last one to 1.5 years, I've been looking at the intersection of AI and ML and politics, and especially about justice and fairness and some of those things, which is what interests me to be part of the web science community as well. So. And prior to joining Queen's about 4 or 5 years back, I was with IBM Research as a research staff member for quite some time, for about 10 years. So I've been in the industry for quite some time as well. So just so you know my background. So yeah, more or less that's about it. So I think I really look forward to listening to the very interesting schedule of talks. Yeah, look forward. Yeah, thanks.
Thank you, Deepak. How about we go with our main PhD participants? So how about we start with, let me go by alphabetically. Alison, do you want to start, please?
Hi everyone, my name is Alison. I am first year PhD in web science at the University of Southampton. As you'll find out in my presentation, my background is music and musicology, and with a love of technology, I found my way to the web science PhD, and I really took a great interest in streaming services because they are so popular, and I really just want to look at the more socio-technical issues that surround those, and I think it's important because it's used by such a large quantity of the population globally.
Great, thanks, Alison. Next, Michelle.
Okay, hi everyone. Yeah, my name is Michele. I'm from Italy. I like Alison. I'm part of the CDT in web science, first year PhD. Actually, I'm based in social sciences because my PhD is in politics, and yeah, I mean, we're going to discuss it later. I'm interested in see how online democracy managed to engage European citizens that live in the UK, which is a big population. So that's basically the focus of my PhD, and yeah, I'm very happy to be here.
Great, thanks, Mikhail, and welcome here. Next is Raksha.
Hi, can you hear me?
Yes,
am I audible?
can.
Okay. Hi, my name is Raksha, and I am a PhD student at Web Science Lab IIT Bangalore. And I come from a computer science background, and we look at social media. Specifically, my research is focused on social media, and we are interested in looking at how social media is impacting the collective worldviews and collective thinking process. Looking forward to this session.
Great, welcome, Raksha. And last we have Steve. Steve, you can go ahead.
Yeah, okay. Hello, everybody.
Hi. So do you want to say a few words about yourself?
Hello, should we try again?
Yeah, we can hear you guys. Yeah, we can hear you very well, all of us.
Okay. Hi there. My name's Steve Anning. Thank you for attending today. My background is, my interest is within exploring humanity's relationship with violence using technology. And that's very much guided by the ideas of peace tech, which seeks to use technology to reduce violence and bring about peace and stability. And I think there's lots of applications for that on the web. So this PhD has been an ideal forum using a socio-technical approach that's blending sort of the non-computer scientists, which I very much am, with the computer scientists. And I now find myself becoming a researcher.
Great. Welcome, Steve. We have actually one more PhD participant. He's having trouble joining from the his side right now. So I will basically keep trying to get him and join us, and we can have his introduction later. And we can start, as Mark said, we can start with the second PhD participant first for the talk. And we can just shift the order. Basically, we can have the first talk, in the place of second, and meanwhile, hopefully, we resolve this issue for him to join, the symposium. So shall we start then with the second presenter for today? So that's going to be Alison. So Alison and Ian, are we ready?
We're ready, yes.
Great. So Ian, let's go with starting with pre-recorded talk by Alison. And we will have then, after the pre-recorded talk, we will have a Q&A session where everybody, primarily, I think the organization of Q&A session, we will keep it from mentor to mentee first. And then if others have questions, they can actually join in, so that we can make sure we are sufficiently giving time to the mentee to get the feedback from the mentor. So that's just, I think, how we have planned. So with that, let's start with Alison's talk.
Hi everyone, and welcome to my presentation for the Web Science 2020 PhD Symposium. My name is Alison, and today I'm going to chat to you about my PhD project, and the title of today is The Role of Genre Within Music Streaming. So today, all I'm going to do is really set the scene for why I'm doing my PhD research and talk about what I aim to do in the future. The reason that I believe it is important to study music streaming services is because of such a large quantity of people globally are using these services. I think it's very important that we understand the socio-technical issues that surround these platforms. So a little bit about me to start. My name is Alison, as you know, and by background, I am a musician and a performer. My undergrad degree was in music performance, and my first master's degree was in musicology, known as the academic study and the scholarly study of music. I'm also a technology lover and a streamer addict, so I found my way to the integrated PhD on web science at the University of Southampton. I'm now in my first year of the PhD, and I am just going ahead to submit my 9-month review. So I'm just going to set the scene today with two components of my study, and I'll talk a little bit about those and then talk about what I hope to do in the future. So first of all, we'll talk about genre. What do we know about genre? Well, I know that they are established. So founded in the 18th century, the term genre was first of all attributed to fine art. It proved to be extremely popular and was then adopted in other disciplines such as music and film and literature. They are culturally rich entities. You will find that people tend to associate music genres to cultural identities or cultural beliefs. And we also tend to find that music genres are found to be socially symbolic, meaning that when changing social trends are happening throughout history, be they social, political, or environmental, we find that music genres by pattern tend to either evolve or be emphasized by their willingness to not evolve. So yes, but we also find that music genres are problematic. So the reason for this is that they are by design amorphous. Even though a genre will not evolve with, say, a social trend, that does not mean that its reception and interpretation will not change throughout the course of time. Genres are not static entities. This can be both good and bad. It really depends on who you're speaking to, I suppose. Someone who has just found a musical genre and experiences it as it is will find it maybe as great, and others will find that a music genre should stay the exact same as when they first ever experienced it, be that a year ago, a month ago, etc., etc. Many genres are also overlapping. Now we find that there are core genres which then spawn subgenres. For example, rock as the core will then spawn hard rock, pop rock, soft rock. That being said, rock itself evolved and spawned from somewhere else. So it's an ongoing sort of evolution, if you will. However, this makes mapping quite difficult. When certain genres connect out of no reason and some completely miss each other out of no actual understandable obvious reason. So there have been attempts to visually map genres. The three that I have listed here are three very good attempts. The problem with mapping genres is that they don't usually manage to keep up. It takes a long time to build the system in the first place, and then you are constantly having to maintain upkeep. We also have the issue of some genres are commercially very successful. I believe I wouldn't be wrong if I said that everyone tends to know what pop music is. However, not everybody will know of another certain genre, because potentially the artist who has developed in that genre doesn't want their music to be commercially successful. That may be a defining trait of that genre. So mapping may be potentially difficult if you're under the impression that you can map every genre that exists. Or this begs the question of, do we accept that we will never fully know everything? Even in the digital age, on digital platforms that tend to try and market themselves as offering you everything. So, speaking of these platforms, music streaming services. Now I will say that for my project, my case study is going to be using Spotify. The reason for this is that Spotify has the most active monthly users on a global scale. I believe it has something like 70 million more than the next best streaming service, which I believe is Apple Music. Therefore, that makes it a pretty good candidate for a case study, in my opinion. So we know that they're popular. As you can see, 47% of global revenue from streaming was in 2018, and that 89% of music listeners were streaming in 2019 on a global scale. We also know that these systems are accessible and convenient. Not only are they accessible and convenient in the term of the model that they use business-wise, meaning that users can access the music for free, but all they have to do is listen to adverts, and they have limited control, but they still get access to free music wherever they want to go, as long as they have a streaming, an internet connection, and my apologies. But we also know that in terms of accessibility, these platforms are multi-platform and multi-device. Spotify is linked to several different social media platforms and also can be played on phones, tablets, laptops, meaning that when we talk about accessible and convenient, we can't just talk about how people are able to use them. We have to also think about how people are sharing them and how these interactions with these platforms has greater consequences. Again, that's potentially a question for another presentation. We also know that these machines are powered by recommender systems. So the three that I have listed here are the three that Spotify use. So content filtering systems, collaborative filtering systems, and also raw audio modeling, which is a very interesting one that I'll quickly touch on. So they use convolutional neural networks to analyze the raw audio data and can produce lists of characteristics. These characteristics are metrics, which some really bear resemblance to musical features such as duration, mode, time signature, key signature. However, you get the idea of the granularity and the engineering side of things when you see some of the other metrics, which is energy, loudness, liveness, and speechiness. Speechiness is a favourite. But these things are also problematic because of metadata issues, for example, which we can describe as messy and in some cases a little bit inadequate. An example of this is classical composers being labelled as artists, which if you listen to classical music you will understand is slightly problematic, as composers are creators and writers, but not potentially performers, as the term artist would sort of dictate. And other things such as when you listen to a track that says featuring artist, the term featuring, if you search it, comes up as an artist, which I don't think I need to explain why that's slightly problematic, because featuring as a person does not exist, or does it? In accordance to actor network theory, we might have to argue on that one. I'm not quite sure. There's also algorithmic bias. I won't go too far into this one, but essentially algorithms are only as good as their creators, which means that if there is limited or incorrect knowledge or not enough attention to detail, that can really have some big consequences in terms of songs and artists slipping through nets of music recommendation and discovery. So these two items put together can really lead to a lot of issues for people on all sides of the spectrum, from the development side to the consumption side. So here we find ourselves in an area where at one end we have Spotify and at other end we have users. By users, I don't just mean those who consume, I mean those who also use the platform professionally, such as artists, producers, distributors, and advertisers. So they both interact with these four sort of puzzle pieces, such as marketing, algorithms, social tendencies in areas, and cultural tendencies in areas, but within the circle of genre, which leads to the next slide, which is where my main key question comes in, which is what is the extent of genre's role as a classification system within Spotify? This then feeds into the next two questions, which is how does Spotify's metadata situation affect the role of genre, and how important is genre to Spotify users? Again, not just the consumers, but the artists and the producers and distributors, and potentially even those at the other side of the spectrum, in the development side, the marketing side, etc. So my methodology is going to be using decentered musical historiography, aka allowing me to view the big picture, almost comparing how genre in the pre-digital age operates now in the present day, and where the really big differences are, and whether or not there's something that can be learned from that. And we're also using actor network theory to assess the conciseness of participants within this network, really looking at who the human and the non-human actors are and how they interact with genre and what the levels of those relationships really are. I then also want to understand genre's role within Spotify's sort of three-tiered structure of music recommendation. These three levels, as you can see down here, which are data, shared models, and features. All three of these levels actually have some level or degree of machine learning involved in each. So I'm really intrigued to see how genre really gets, how important it is to those three levels. My research methods, they're going to be an interdisciplinary blend of quantitative and qualitative. So using the Spotify API and Python, I'm going to look at the audio profiling metrics and the ranges. So I'm going to examine the features of songs in themed playlists and then also comparatively in non-themed playlists. I want to see how Spotify, as a streaming platform, has tried to engineer culture into mathematics, essentially. I want to see how numerically they have engineered this translation. And then we're going to be looking at qualitative. So due to the virus, things are a little bit up in the air, and I'm still thinking on this one. But I would like to speak to semi-structured interviews, interview users, again, not just people who consume, but people who use the platform professionally, such as creators and artists. And I also want to potentially speak to those at the other side of the spectrum. If I can do that, we'll have to wait and see. I'm just at the 9-month part, so I'll need to hold tight and see on that one. But yes, hopefully these research methods will give me the ability to build a much greater picture, a better understanding. So yeah, that is my presentation. Thank you for listening. And does anyone have any questions?
Great. Thank you, Alison. This was a very timely done and very well done talk. So we can give opportunity to the mentor to first start the question session. So Deepak, you can go ahead and start with the Q&A session, please.
Okay. Thanks, Alison. So it was a very interesting talk. I mean, especially I think this is probably a space which is very less explored. So I think I mean there's some potential to do some substantive work here. So I had a few, I mean, not really questions, but just a few comments. You talked about genres being amorphous in the and in the sense that there might be overlapping. There might not be strict classes as such. So one possibility to look at it from a computational aspect could be like what are the implications of that of that nature of genres to maybe things like classification task and so on, or recommendation in general. Like when you upload something, what does it? I mean. If a machine learning system is trying to identify the genre or something, what are the possible kinds of issues that it could have? For example, maybe would it mean that maybe fuzzy methods are to be used, or some other kinds of things? So that is so the implications of that nature of genre is to computational tasks is something that might be interesting to look at. I mean, I'm just saying it may not be in the scope of your own PhD, but I just thought of mentioning it nevertheless. So, and another thing that I think I'll just mention all my comments, and then maybe you might have some responses. So, one thing is the dynamics between recommender systems and genre. And for example, recommender systems are known to have certain undesirable effects, like for example in the political spectrum, like recommender systems don't like people who are in the center because they're not so easily predictable, and they kind of I mean, if you have a slight left bias, then you're pushed all the way to the left by just repeatedly showing left-leaning articles, etc. So is there some kind of some aspects of the interplay between recommender systems and this nature of genres, and whether it undermines the multifaceted nature of a music, I mean, of people who appreciate music and so on. So that might be something. When the work that has been done in the space of politics is itself very limited. So I would think that there would be very little work in the space of. So basically, are you leading people into echo chambers in a way where you're only recommending things based on what you know about them, rather than allowing them to explore a little bit? And another thing that you interestingly touched upon slightly is this asymmetry in recommender systems. For example, I mean, are there artists in like very niche areas of the music space who tend to be disadvantaged by way of recommender systems? For example, like let's say that you're looking at you find the k nearest neighbors of every I mean, like let's say that there are a bunch of data points. In this case, it might be music pieces, and you find the k nearest neighbors. And then some of them, some data points might figure in the k nearest neighbors of a lot, whereas some others may not be in the k nearest neighbors of many, right? Some may be kind of isolated in some part of the space and so on. So you might want to, I mean, one interesting question in the space could be, what are those things what are those music pieces which are in that disadvantaged territory? Are they like unconventional tastes? Are they minority tastes? Are they emerging new strands of genre combinations and so on? So and one last point that I would like to make is, I mean, some genres have some kind of interactions more culturally and politically positioned, right? For example, rock, I mean, in general has a particular political connotation and so on. So this might bring in a number of different things into the mix when you deal with those things, in addition to just a music appreciation part of it. There are other aspects that might need to be considered and so on. So overall, I think it's the space of I mean asymmetry and fairness and so on around this recommender systems in this space is quite rich and could be quite interesting. And well, I don't have any questions. I said these were broadly comments, but I'm happy to know your responses if you would like to just briefly.
Thank you. That was a lot of actually really helpful comments. Some of them have popped up previously in the past during areas of researching and things like that. So things that have sort of popped up before have been the idea of the echo chamber that you mentioned. I remember coming across certain research that looked at if certain streaming services and the way that their recommendation worked, if it tended to be quite isolating to, for example, in the folk music space. I think the artist Damien Rice was the example point, and they essentially looked at who was recommended as, for example, the Neighbours, and who was being pushed forward as a similar artist and things like that. It actually ended up being I think conclusive that the music was a very tiny percentage of what was actually being recommended. What ended up being really recommended was these similar artists in terms of gender and of race. So there has been many, I think, sort of sociological investigations into the equality behind these sort of these systems. But right now, the idea of looking at it from the music perspective, I haven't really found fully anything that talks about unsatisfactory things. I think that's really interesting. One thing that I have came across previously and looking around at genre as a pre-digital age was that genres usually have a trajectory where they start off as avant-garde, they become scene-based, they then become industrial, and then they become commercial. What I've found is that music streaming services, so far this is more of an opinion than something that I've obviously grounded in research because I'm only at the 9-month stage, but we found that it sort of really mixes up these trajectories, and the recommendation is a really key part in that. I think that your comments have been super helpful, and I will hopefully be able to give you more, I suppose, in-depth answers in the future. I guess my answer, maybe unfortunately, to a lot of questions may just be, I'll get back to you in a year. but thank you so much. That was really helpful.
I think just one quick point, one that you mentioned right now is like when you're doing recommendations, you have a lot of this metadata which are more structured, semi-structured, etc. And recommender systems have traditionally worked with that as against the content of the music. So I mean, preserving the primacy of music in the recommendation part of it might be, would be very interesting. Yeah, thanks.
Thank you.
Great. Since we have one question, I'll let Steve jump in to ask that question. Steve, could you please unmute and go ahead? I think. Okay, so I'll just go ahead and ask his question because I think he is on the attendees link now, it seems. So his question is, do you find that already popular artist songs, such as Ed Sheeran and Taylor Swift songs, dominate recommender systems? And if so, how do you build a recommender music system that encourages people to discover new music?
Oh wow, that's a big question. So I would, funnily enough, say I think that's the question that a lot of people that work at these streaming services are asking. So I know that in what I've been studying, that there's obviously a bit of an agreement between certain record labels, and there's trade-offs in terms of like they pay for certain artists to dominate a certain slot in a playlist for a set amount of time. I find that it would, as Deepak was saying, a lot of the time it's about popularity and features over the actual music itself. And when an artist is already very popular as it is, like you're saying, they do tend to dominate the recommender systems, because you also find that when people who are using the free service don't really have control over who they can skip songs and move between. So you will find that a lot of these already very popular artists, that the big three, so Sony, Universal, Warner, who all own, for example, in Spotify, they all own a share of Spotify, they will be placing the artists that they have invested interest in at the top of these playlists, because I believe there's a study that shows that it's very important to be in like that top 10, because then user interest starts to decrease as you go down the playlist. But how do you build a recommender system that encourages people to discover new music? I feel like that's a really big question that I'll only probably maybe even be close to answering a bit further on, but it is definitely a really important question, because I think there's definitely elements that need to be addressed, such as fairness and equality, and that's where we fall into things like algorithm bias and things like that. My supervisor has actually previously encouraged me to carry out a thought experiment to try and think about what the ideal recommender system would be, and I've yet to actually do that, but maybe I'll shoot you an email after I've done it.
Can you hear me now?
Yeah.
Yeah, I think what you're doing, like sort of particularly with what's going on at the moment, is really quite important, because if music venues and sort of cultural venues are sort of facing all the problems that we can see in the last week, then what is actually going to, I've just managed to start my video. So with sort of cultural venues that are going to take a hit over the next few years, it's how are people going to discover new music? And if and beyond the points of fairness, it's actually in the music industry's interest to not have vested interest in a small group of artists, they need kind of a pipeline of new artists coming through. So it's almost as a business question of how does the music industry create that pipeline of new artists that people are interested in, when maybe the concert venues where they would have previously got the buzz from, previously got their following from, may not be as helpful over the next couple of years.
Yeah, I definitely think there's something to be said there. As the streaming services, yes, a large quantity of the population use them, but there's still obviously a very large quantity that don't, and people who prefer to experience music live or in a different format, like potentially not digitally. They prefer, I don't know, vinyl, for example. There's been a huge resurgence in vinyl. So it's basically going to be, it's almost very much like a lot of people have been forced online given the current closures of things. People have had to learn to adapt and all of these sort of things. But I think you'll find that, for example, Facebook have just they're in development of a new app, or it's maybe already come out, I'm not quite sure, I saw this weeks ago, and it's called Collab. And it's about, actually, they've clearly seen the popularity in these online meeting spaces that musicians have, you know, been live streaming on Facebook, or they've been live streaming on YouTube, for example. And they have created an application that it is purely made for people to collaborate to create music. So there is already signs of adaptation to what we've been dealing with in the past, but with every new sort of revelation, I suppose, comes its issues. So we'll just have to, I guess, wait and see. And as I've just sort of mentioned in the presentation, like computationally, you're dealing with something that is quite messy if you involve all of the key characteristics, if you take the big picture into account. Whereas when you try to slim something down or really just cut corners, you have to think about who really faces the consequences, who is it that's really affected.
Yeah.
So yeah.
Thank you.
Rant over.
Michaela, please go ahead.
Yeah, sorry, can I ask something? I mean, I don't know how to do it through the Q&A, so anyway, I want to ask Alison, I mean, I think maybe you partially said already, but it's probably not within the scope of your research, but is there any study or statistics or anything about, you know, how actually YouTube is impacting the Spotify and all this kind of software that, you know, suggests music to user? Because I know a lot of artists actually come out of YouTube nowadays. You know, those that are not actually don't get a contract with a big music company. I know some of them, they became famous thanks to YouTube. I don't know if there is any link, like proven link with like people. Just wondering.
Honestly, I've not really came across any stuff with YouTube, just because I've not been looking that way. So actually, that's probably a really good observation or a question, because I'll need to look at it at some point. Because when you watch these things, you're still technically streaming it. So no, I've not come across anything yet, but I do know obviously that it is a very, very popular platform, and obviously that's where a lot of people upload, for example, like official music video on their channels and things like that. But I don't specifically know, apart from maybe a report that I read from IFPI, but apart from that, I couldn't. I'm not gonna throw a statistic at you, because it's most likely going to be wrong. I'd have to go search for it.
Yeah, I wouldn't know. So I would believe you. I wouldn't know. So
I think it's in the references at the end of the slideshow.
No. I think that that would be interesting to know. Actually,
but you know, that's a really relevant question. Of course.
All right, so I think we are also right there for the time limit as well. And I think it was a pretty good Q&A session and a lot of interesting comments, Alison. I hope you benefited from it. And you will have more chance to also interact for more Q&A with the mentors in the session later that we will have. So we can now move on to the second presenter. Let's thank Alison one more time, everybody. So we will have a virtual thanks to Alison in this case.
I can just jump
Mark,
in a second.
yes, Mark. Yes, go ahead, Mark, please.
I just wanted to flag up, because we've got about 20 or so people in attendance aside from the main panelists. And if anybody wants to ask any questions, the Q&A facility is open in Zoom. Type your questions in there, we can read them out. But if we don't have time to get through all of them, then that's a very useful resource for our presenters as well, to give them more stuff to think about. So feel free to post stuff in the Q&A session as well.
All right, thanks, Mark. So next presenter we have is Khalud. Did I pronounce your name correctly, Khalud? So you can correct if I did not pronounce it correctly. So welcome, Khalud, for the second presentation for the session. And she's presenting, I think, live right now, because is that correct, Khalud? Yeah.
Yes. Hello.
You're
Good
all
afternoon.
set. Good afternoon. And you're all set up?
Yes.
Yeah,
My name is
okay.
Khulud. So yeah. Thank you so much. My name is Khulud. I am from Saudi Arabia. I am in my second year of PhD, and I'm doing my PhD on the King's College on the informatics department of the informatics. So now I will share my my screen to start the presentation. So hopefully my screen is shown.
Yes, it is shown now. You can start, Khalid.
Okay, so my project is about designing a task recommender system for Wikidata. My supervisors are Professor Elena and Dr. May from King's College. So I will start by stating my research aims. In my study, we develop in the current study we develop a task recommender system to recommend items that require editing to editors in Wikidata in a way that considers their interests. I mean by their interest is the recommendations are based on editors' past editing behavior. So we aim to create a foundation for understanding how Wikidata items can be recommended to editors. We also aim to examine whether implementing the proposed system would support editors in Wikidata and increase engagement. I mean by support editors is to help them in finding the tasks that they would like to complete and they would be able to complete. So what is Wikidata at first? Wikidata is a community-driven, freely available knowledge graph that is edited collaboratively by the crowd. What it means collaboratively by the crowd, it means that Wikidata has a strong focus in human intervention because the main mission of Wikidata is to present human knowledge in a structured way. So the community in Wikidata is responsible for all data management and control. Accordingly, the success and sustainability of Wikidata are linked to the existence of an active community. This means Wikidata needs to keep its community alive. This is the main challenge in Wikidata, is to keep its community alive by attracting new editors to the community, by retaining the existing members who already approach Wikidata, by motivating community members to contribute, and by supporting them during their editing experience. Wikidata is a large knowledge graph, and as Wikidata increases in size and complexity, there is much data and many tasks on work need to be worked on. So for this, it is challenging for editors, particularly novices, to find tasks that they can perform and they can enjoy contributing to. But novices I am here focusing on novices because novices are new to Wikidata. They are less familiar with the platform, and they don't have much experience in working with the structured knowledge graph like Wikidata. So in Wikidata, routing editors to proper tasks is not properly supported. And this may cause, and this explains the high number of early dropout in Wikidata. So helping this kind of editors who are novices, who are new to the platform, in finding their way into editing Wikidata and encouraging them to make contributions can encourage their commitment, can support them in becoming more established editors and in performing valuable tasks. And this ultimately will increase the retention rate in Wikidata. In this regard, the recommendation system as a tool, as we can see from the real world application and from the literature, the recommendation system aims to make the selection process easier and more predictive by providing individuals with the most suitable list of recommendations from the overwhelming number of alternatives. So for this, recommendation system is also useful, is also a useful tool for enhancing the user experience and increasing the engagement between user and the platform. In general, the problem statement is we conduct this study to understand if Wikidata's community will decide to implement recommender system for tasks, for editing tasks, what will be the ground? What is the basis for the system? I mean, what are the features of the system? So we need also to give the community, the Wikidata community, the opportunity to receive recommendations based on their interests and examine whether this changes their engagement. And here I am explaining the major stages to build and to design the proposed system. The first stage is the data acquisition, which is already finished in the first year. In this stage, I collected all the data sets I want from Wikidata. The second stage is data pre-processing, is to prepare the data that I have, which is about Wikidata items and Wikidata editing history, to prepare them to be used for the recommender model. And the third stage is to develop the recommender model using different and various recommendation algorithm. And I will explain this in more details later on. The fourth stage is to generate recommendations, sort all the lists produced by the model, and select the top in recommendations to present it to the end users, to the editors. Here is the steps to develop the recommender model. So basically, to develop the recommender model, I need the data set that is about users' past editing data. First of all, the data is split into training set and testing set. The training set is fit to be used using different recommendation algorithms to train the model to be able to produce valuable list of recommendations to the editors. So after I train my model using different recommendation algorithms, I will have the learned model, which is the recommender. And now it is the time to evaluate the trained model using the testing set, which is the unseen data that I hold it out from the training. Using the testing set, I need to evaluate the model against various evaluation metrics to assess the performance of the model and to assess the accuracy of the model. And then the evaluation results will be produced. Based on the evaluation results, I will back to the model to try to optimize the parameters of the model. I mean, tune the model to get better results and high quality recommendations based on the evaluation results. So The tools and packages that I am using. First of all, when I collect my data, I have used 2 Wikidata DOMs that is publicly available by Wikimedia. All DOMs were parsed to obtain the data that I want for my experiment. And then the data set is stored in the Postgres database. The volume and the size of my data set, in total, there are 800 million interactions by 200,000 users with 50 million items. And I use Python to perform data preprocessing, feature engineering, modeling, training, and evaluation. This is the most libraries that I use it to build and to make my implementation. For the recommender approaches and algorithms, I use different approaches for the recommendations to build my model. There are different approaches that I adopted in my experiment. The first one is collaborative filtering recommender. In this approach, it used the concept of the similar users. It recommends items to the users based on the similarities between users, based on the similarities in their editing test. And here to build this model, I use various model-based algorithms to train my model, which is matrix factorization, SVD, SGD. These are the name of the algorithms that I use it to build this approach. The second approach that I want to build it is content-based recommender. In content-based, in this approach, the recommendations are generated based on the attributes of the items, which is make the recommendation based on the history of the user and using the similar items that users have been edited in the past. Here I use similarity matrix using cosine similarity, and I build my feature representation using back of works and word to vector algorithms. The third approach that I adopted is popularity-based recommendation, is to recommend items to all users based on the popularity of the items. Finally, I will build a hybrid recommender, which is mix of all these models together to build like a resemble model that's included all these models: collaborative filtering, content-based, and popularity recommender. Finally, in the evaluation, currently I use offline evaluation using the data set I have, which is users' past editing data, to evaluate the algorithms, to evaluate the accuracy and performance of the algorithm. The two strategies that I use to split the data is two cross-validation strategies, which are leave one out and hold out strategy. And the two matrices are adopted to assess the ranked list of recommendation are hit ratio and NDCG. For my future work, I plan to add more sophisticated algorithms, more sophisticated recommendation algorithms to enhance the results. I also plan to use more metrics for the evaluation, and also I plan to optimize and to improve my model and find the proper techniques that can address the cold start problem with the new editors, because new editors don't have enough historical editing data. So this is called cold start problem. I need to apply proper techniques to address this problem and to ultimately improve the system. And finally, I'm planning to conduct a user study to examine the impact of the system for editors in the real world in terms of the engagement. And this is all. Thank you so much. And in case there are any questions, you are welcome.
I sometimes search for, exotic islands in the world, but I don't know anything about the geography or cultures of those islands. I'm just exploring, but I'd like to explore those. So I won't be I won't be the best person to edit some of those articles, but I might enjoy looking through some of them. So there might be some interesting trade-offs between those two aspects, which it seemed like very intriguing to me. So overall, the broader comment that I have is, instead of looking at it just like another domain for recommender systems to work upon, I think there might be some specifics within the Wikidata domain which might help you look at problems which nobody else might have looked at all, because of the special nature of this domain. So that might be something that you might want to look at later.
Yes, thank you so much. I totally agree with you, because yes, what I'm building is not like a classical recommendation system, as you said, because I'm working on the different domain, which is knowledge graph, community-based knowledge graph. So, for example, in the classic recommendation system literature, users, for example, in the Amazon or in the any e-commerce website, users usually, or also in the movie literature, for example, Netflix, we don't recommend the same movie that users watch it in the past. But here in my domain, I need, it's preferable to recommend the same item that user has edited in the past, because users would prefer to edit the same items that belong to the same topic, the domain topic that they preferred. That's why I am materialize. One of my contribution is to materialize Wikidata items to build taxonomy, to know each items or each set of items belong to which topic, to understand my users, to understand the editors, you know, to build a high quality recommender system. Yes.
Yeah. Okay. Yeah. Thanks.
Thank you so much.
Thanks. Any other questions from the audience, participants?
Yeah. So any other questions from the participants? And if any from attendees, you can raise the hand and I can enable you to talk. All right. I think from the attendee side. So I have one question from basically I've been in the space in the knowledge graph space a while back in my career, and I've looked at actually semantic web, where actually knowledge graphs, like a lot of folks in the web community consider knowledge graph as a new name towards what semantic web, the semantic networks used to be, right? And so in that, when you're talking about the task recommendation and actually the quality, for the kind of task recommendation you are giving, right? What is its implications actually for the quality of what gets actually generated? Because you were talking about actually knowledge graph, that's what's your core is, and that will impact that will influence a lot of applications that might be actually dependent on, that knowledge graph, right? For example, we see Wikipedia, we use it in several applications actually. So the quality of what Wikipedia is really matters. And that's where a lot of people questions the incompleteness, the challenges with the incompleteness, inaccuracy in the links that are there or the labels that have been given, right? So have you thought about this quality aspect as well when you are actually thinking about the recommendations for the task?
Yes, this is really a good question, because yes, at the start, when I start thinking about building recommender system, or when I start thinking to route people to the suitable tasks, I was really aware to enhance the quality of the contributions that user can make for Wikidata, because like you said, Wikidata really matter for the other platforms. There are really a lot of databases that build upon Wikidata, and governments, libraries that all build upon Wikidata. But later on, right now, because there is no recommendation system at all in Wikidata, I focus my study, or my study focus is to build the recommender system to see how can I route user to the suitable tasks, to see the impact of this on the user engagement, and I lift this quality aspect to the future to see, because it is really interesting aspect to check it for the recommendations result. Yes.
And there is an interesting question from the audience as well. So particularly Aris has this question that how do you manage the changes in the data set every time a user edited an article? So that is also, I think, important if you think about recommendations. So what you are building the recommendations on, or from where you are sourcing what you're recommending. So any comments and thoughts on that?
Yes, actually my data set, when I collected my data set is cover all the period since the Wikidata started until the 1st of July when I downloaded them. So it's cover all the activities, editing activities using users have performed from the 2012 since Wikidata started until 2019. When I running my experiment, I sample, I make data sample from huge data set, and one of the feature that I use it to train my model is the edit time, because edit time is really matter in understand the user behavior. If user edit, for example, item belong to the politics, and then edit items belong to the country, and then edit items belong to the city in this series, it is different than other users who edit items in different order. So edit time is matter for me, and I use it as a feature to train my model using it. I hope I hope I already answered your question. Because yes, I use this as a feature to train my model to understand the different edit time using users edited the items.
Thank you. Okay, great. So I think we are pretty much on time for the next part of the program, right? And with that, I want to actually thank Khalud. So let's thank Khalud virtually for a great talk and great interactive session. So now we will have the social engagement session. So it's a session where actually we can have, you know, attendees have interactions with the PhD students, and PhD students among themselves can have interactions for asking questions, because we had a limited time earlier, and perhaps you had, like, as I saw in Q&A, some of you have some questions, but you know, cannot be just taken care during the Q&A period, because that was a small period that we have. But given the time bound, we have to be, you know, basically aligned with the time limits. So with that, I would open the social engagement session, and please feel free to have discussions as you wanted to ask some questions earlier, and if you haven't, to the already presenters, you know, who have given the talks, please go ahead, do that, as well as if you are interested in other aspects of the you know, talks that they haven't touched upon and want to discuss, please have those as well. So we will have like that kind of an open discussion sort of session here, and as well as social engagement session for the PhD students. So please feel free to start on that. And yeah, meanwhile, mentors and actually the co-chairs, we will just take a break and we will just let you have, because sometimes, you know, mentors can affect the the interactions of the students. So we'll step out for a moment, and we will be back in 30 minutes. And meanwhile, you can have this the social engagement session. So with that, yeah, I'll let the social engagement session be started.